In this question here, we are given a graph of g of x and a graph of h of x. So in 8.1, we are asked to determine whether the graph of h intersects the graph of g at its point of inflection. Show all necessary calculations. So the first thing we're going to do here, we're going to write the equations of our graphs. So the graph of g of x is equals to x cubed minus 3x squared, and the graph of h of x is equals to minus 2 over 3x minus 4 over 3. So we are asked to determine whether the graph of h of x intersects with the graph of g of x at its point of inflection. At its point of inflection. So for us to solve this problem, we must first find the points of inflection of the graph of g. So we first find the first derivative, which is 3x squared minus 6x, and the second derivative, which is equals to 6x minus 6, right? And for us to identify whether or not it intersects with the graph of g at the point of inflection, we must first find the point of inflection. So we equate the second derivative to 0. So 0 is equal to 6x minus 6. And then 6x is equals to 6 divided by 6 both sides. X is equals to 1. So this is the point of inflection. So we want to know whether the graph of g of x intersects the graph of h of x at this point of inflection. So now we're going to substitute the graph of we're going to substitute x at g of x. So it's g into x equals to 1 being equals to 1 cubed minus 3 into 1 squared. So we are substituting the x value in the original equation of g of x, right? So which is what we did here. So the answer that you should get, it's minus 2. So this is the solution of y when you substitute x being equals to 1. So we have to substitute the same value of x being equals to 1 on h of x to see if it's going to give us the same y value. So h when x is equals to 1 equals to minus 2 over 3 into 1 minus 4 over 3. So if you punch your calculator, you should get minus 2. So the fact that we are getting same values of y when we substitute the same value of x, it means now that the graph of h of x intersects with the graph of g of x at its point of inflection. So now 8.2, we are asked to determine the stationary points of y, which is equals to g prime of x, and classify these stationary points as either maximum or minimum. So what you're going to do is we want to identify the stationary point first. So we know that g of x is equals to x cubed minus 3x squared. So to find the stationary point, we have to find the first derivative of this cubic function, which is 3x squared minus 6x. And we equate to 0. So we have 3x squared minus 6x equals to 0. Then we factorize 3x, and we are left with x minus 2. So let me write this 2 properly. So we're going to be left with x minus 2 equals to 0, and 3x being equals to 0, or x being equals to 2. So x equals to 0 or x equals to 2. So these are the stationary points. So we have to identify whether or not they are at a point of minimum or maximum, right? For the graph of y is equals to g prime of x, which is a parabola. So what you're going to do is we're going to substitute these values here, x equals to 0 and x equals to 2 in the graph of g prime of x to find the y values, right? To find the y values. So when g prime of x, when x is equals to 0, what is our y value? So we're going to substitute them in this equation here. So it's going to be 3 into 0 squared minus 6 into 0. So basically our y is 0. And then when g prime of x, when x is equals to 2, what is our y? So it's going to be 3, it's going to be 2 here. squared, and then there's 3 outside, minus 6 into 2. So you're going to get 3 times 4 minus 12, which 3 times 4 is 12, so it's going to be 12 minus 12 being equal to 0. So this confirms now that when x is equal to 0, y is equal to 0. When x is equal to 2, y is equal to 0. So to draw our function, because we want to know whether or not this function is a minimum or maximum, right? So we're going to draw it. So when drawing our function, we need to identify our intercepts, right? Because if you derive a cubic function, you're going to get a parabola, and the derivative of a cubic function gives you turning points of a cubic function, but the derivative of a cubic function gives you the intercepts of a parabola. So these are the intercepts of a parabola, x equals to 0 and x is equal to 2. And we substituted into the parabola equation to get the values of y. So y is equal to 0 and x equals to 0, and y is equal to 0 when x is equal to 2. So having our intercept being equals to 0 and 0, and also have 2 and 0. So we're going to indicate, so this is a point where we have 0 and 0, and this is a point where we have 2 and 0. So these are our intercepts for this problem here. So for us to draw the function, we need also to identify the turning point of the function. So the g of prime of x is equals to, remember that the derivative, because our g of x is equals to x cubed minus 3x squared, when you derive, we got 3x squared minus 6x, and to find the turning point, we have to find x of t, which is equals to minus b over 2a, of which our b in this case is this minus 6 here. So it's going to be equals to minus into minus 6 divided by 2, and our a value is going to be this 3 here. 3, and you should get 1. So your x value of the turning point should be 1. And when you substitute that x value into this function here, g prime of x equals to 1, you should get a y value of minus 3. So your turning point of this function is 1 and minus 3. So we need to indicate them here. So when x is equals to 1, our y value is minus 3. So this would be the turning point of the function. Then we draw it, so it's going to look something like this. It's going to look something like this. So because this parabola here, it is a smiley face. Normally when you say it's a smiley face, it's when a value is greater than 0. Then you know it's smiling. But when a is less than 0, you know it is sad, right? So this one is a smiley face, meaning that it has a point of minimum. This is the minimum value of y, which is equals to minus 3, having the x value being equals to 1. So hence we can define the function as a point of minimum. So the point of minimum, it is when y is equals to minus 3. Now 8.3, hence or otherwise, determine 8.3.1, determine the values of x for which the graph of g is concave down. So when something is concave down, which means it's facing downwards, right? So it's when you have a parabola that is facing downwards, but if it's concave up, it is facing upwards, right? So please note it down. This is concave up, this is concave down. So in we normally call this convex, and this is just concave. So yeah, for concave down, we are focusing on this shape. So what we need to do here is we need to find the point of inflection. So the point of inflection, it helps you to interpret the concavity of your cubic function, right? So what you're going to do is this. We're going to write our our g of x, which is equals to x cubed minus, so it's x cubed minus 3x squared, and find our points of inflection. So first derivative is 3x squared minus 6x. The second derivative is equals to 6x minus 6. So we have to first find the point of inflection. We equate to 0, then 0 is equals to 6x minus 6. Transpose the 6 to the other side, you have 6x equals to 6. Divide by 6 both sides, so therefore x is equals to 1. So this is the x value of the point of inflection, right? So we're going to use it to interpret the concavity. So what you're going to do is we're going to draw our function. Let's draw our function. We're not going to draw it to scale or draw it accordingly, but we know that here our g has a being greater than 0. So it's a is equals to 1, meaning the gradient is greater than 0. So when your cubic function has a gradient that is greater than 0, it means that it increases, decreases, and increases. So when a is greater than 0. But when a is less than 0, you'll have a cubic function that decreases, increases, decreases, right? So in this case, we are just looking for this one, which increases, decreases, and increases. So we have already identified the point of inflection being equals to 1 here. So meaning, let's say for example, this is 1. This is not drawn accordingly, just so you know. So this is x equals to 1. So now, to identify the concavity of this function here, we are going to say, because we are looking for concave down, so for concave down, so for concave down, as I said, concave down looks like that. It's concave down. So if you look at this cubic function, which part is concave down? Definitely this part. This part is concave down. It's looking downwards. So meaning if x is equals to 1 here, so to interpret the x values when the function is concave down, you're going to say when x is less than 1, the function of g is concave down. So this is the solution that you're looking for, x being less than 1. So now 8.3.2 says that we must determine the gradient of the tangent to g at its point of inflection. So what we need to do here, we need to use the same value that we use for the point of inflection. We have already identified that the point of inflection x is equals to 1. And we want to identify the gradient of g. So the gradient of g, it is its derivative. So if g of x is equals to x cubed minus 3x as given, so its gradient is its derivative. So we derive this, we're going to get 3x squared minus 6x. So we're going to use this point of inflection to identify the gradient of this tangent. So we're going to say g prime when x is equals to 1 is equals to 3 into 1 squared minus 6 into 1. So you're going to have 3 minus 6, which is minus 3 here. So the gradient of this tangent, it's minus 3. We are going to do 8.4. So 8.4 says that determine the value of k if the graph of g is shifted so that the values of x for which the new graph, so there's a shift of the graph of g, and this is a shift, x plus k. So we are told that the shift causes the new graph to decrease in these points of minus 3 and minus 1. And we are asked to find the value of k when that happens. So the first thing we're going to do here, we're going to identify the gradient of the equation of g. So we know that g of x is equals to x cubed minus 3x squared, right? And we are told that there's a shift. So the shift is x plus k, right? So we want to find the value of k. We want to find this value of k here, right? So we are told that there's a decrease of p of x, it lies between minus 3 and minus 1. So the decrease lies between these 2 points, meaning that if we were to take a point, So it's going to be minus 2 because minus 2 lies between minus 3 and minus 1. So please take note of this. We're going to comment it later. So we need to first find the derivative of this function here to identify the value of x. All right. So it's going to be, why am I identifying the value of x? So that it's going to be equated to this expression here. So to derive this, you're going to have 3x squared minus 6x. Remember that we are told that the gradient is decreasing. So if the gradient is decreasing, it means now that g prime of x must be less than 0, right? It's decreasing. So we're just going to write this expression here. So it's going to be 3x squared minus 6x less than 0. Then you factorize, it's going to have 3x into x minus 2 in less than 0, like that. Then you find the critical values, which x is equals to 2, or this portion here, which is 3x being equals to 0. So divide by 3 both sides, so x is equals to 0. So these are your critical points. These are your critical points. Both of them are your critical points. So what you're going to do is this: you're going to draw your number line and write 0 there and write 2 there, and then you're going to test in your number line. You're going to test values before 0, which is maybe minus 1 or minus 2. You're going to test all those values. Even between 0 and 1, you're going to test it's 1, and after 2 comes 3 and 4. All those values you're going to test. Why are you testing? You want to identify the signs that lies between these numbers. So when you are done testing, if let's say for example you're going to test this value of x being equals to 1, so you're going to use your equation. Remember that your equation is this one here. It's this one here. So you're going to substitute x equals to 1, and the value that you find there, we are interested in the sign. So the answer you're going to get a positive solution, meaning that between 0 and 2 there's a positive solution of y there. And then before 0 you're going to test either negative 1 or negative 2. You're going to substitute them into this equation here. So when you substitute, you're going to find that you're getting negative solutions of y. So your answer will be negative, so meaning your negative solutions of y. You're going to do the same here, test 3 or test 4. In this equation here, you're going to substitute. Where there's x, you put 3 and put 3 and find the solution there. You're going to get a negative. So remember that in our problem, we are mostly... when you test your values, you will note that between 0 and 2, you're going to get a solution of negative. And then when you test any value between minus 1, minus 2, you're going to get a solution is positive. And here also you're going to get a solution which is positive. When you substitute these values here into your equation here, you're going to get these signs of y, right? So once you've done this, remember that this question says that find the values of x when the y value is less than 0. So this is where the y value is less than 0. So meaning that this means now that your x values lie between 0 and 2. So to conclude, you will simply say your x value lies between 0 and 2. And remember that we're still not done. We want to find the value of k. Let's take this expression here. The shift. So there's a shift of x plus k, right? There's a shift of x plus k, and we are also told that the graph of p of x. We are also told that the graph of p of x decreases at these points here at between minus 3 and minus 2. So the p of x decreases at points between minus 3 and minus 1, right? So you're having all these conditions here. You have this condition, condition 1, and we have this condition 2 here. So what you're going to do is you're going to say x plus k is equals to what? It's equals to a solution, right? So what solution is that? You know that the function of p of x decreases between minus 3 and minus 1. So what is the value between minus 3 and minus 1? It is minus 2. So we are interested in this minus 2. So it means now that here, instead of writing x, you're going to write minus 2 plus your k value being equals to. So the solutions of x, remember that we are trying to find the solution of x here at this point here when we're dealing with our inequalities, and we found that our x value must lie between 0 and 2. So what is the value between 0 and 2? It's when x is equals to 1. You're going to say it's equals to 1. This expression is equals to 1. So you're going to transpose this minus 2 to the other side. You're going to have k is equals to 1 plus 2, which is equals to 3. So our k value is going to be equals to 3. So this is the solutions of k when there's a shift of x plus k. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.